Okay, this video is about measurement precision. As I said in class, measurements must reflect the precision of the instrument used, and the last digit is implied to be an estimate. So let's take a look at a figure that looks similar to the one you saw in your textbook, where we have a graduated cylinder filled with liquid, and we see that there's a meniscus here, which is the concave down shape, and the convention is to measure from the bottom of that meniscus. So the person viewing the meniscus believes that the bottommost portion of that meniscus lies exactly on the second tick mark after the 30. So therefore they would have to report the volume to the 10th decimal place, because you can report one beyond the markings. So that 0 is implied to be an estimate. Perhaps the bottom of the meniscus is a shade above that tick mark or a shade below. We don't know. We can only estimate that it looks like the tick mark falls exactly at the bottom of that meniscus. Now let's take a look at some length measurements. So here we have 4 meter sticks, and there are varying levels of precision, just as I showed in class. The top meter stick has no markings whatsoever, so the best we can do is estimate to the 10th of a meter. So the reading that we might get for measuring the length of that yellow paper or yellow object, assuming the yellow object starts at the beginning of the meter, might be 0.8 meters. So we're eyeballing that 0.8 of a meter because we have no markings to go on. All we can do is estimate. So the 8 is an estimate there. The next meter stick is designed so that we can only see, pretend we can only see the 10th of a meter. So that would be 90 centimeters or 0.9 meters, and then we have 0.8 meters over here. So the best that we could measure using this kind of meter stick would be 0.80 meters if we believe that the end of the yellow object aligns perfectly on the marking 4.8 meters. And so the second reading would have 0 as the estimate. The third meter stick is designed, didn't quite accomplish it here, but all of these small markings between the numbers, let's pretend we can't see those. So we have 84 here, and then down, if we go down, that's 83 centimeters, and then it would be 82, 81, and then this location right here would be 80 centimeters or 0.8 centimeters, but we would not see the smaller markings. So if the whole meter stick were like this, then the best that we could do with our measurement would be 0.800 meters. In this case, we know that we know the 10th of a meter, we know the 100th of a meter, but the 0 is really the estimate there. The 0 in the hundredths or thousandth place, sorry, tenths, hundredths, thousandth place is an estimate. And finally, the full-blown meter stick with all of its millimeter markings we would be able to estimate the length of this yellow object as 0.8000 meters. One way that you can think of this, let me erase this so we could take a closer look. Sometimes these zeros can throw you off. So let's pretend, for example, that the yellow object came to somewhere in here, a little bit beyond 82 centimeters or 0.82 0.82 meters. So what if the yellow object came to this location right there? Then we would all agree, I think, that we are above 0.8 meters. We are over 82 centimeters, or 0.82 meters. And then we're definitely past the third tick mark, but we're not quite to the fourth tick mark. So we might say, well, we're almost to the fourth tick mark, but not quite. So maybe we estimate that we're 8/10 of the way there to that fourth tick mark. So right in there, fourth tick mark. So sometimes, again, these zeros can throw you off in this kind of number. So sometimes it's helpful to say, well, what if the object fell somewhere else on the scale? To what decimal place would you be able to estimate? And here we can see it's clearly the 100,000, let's see, 10th, 100,000th, 10,000th of a meter.